In this video, we're going to talk about the combustion of ethanol. So ethanol, when it undergoes combustion, all combustion reactions require the input of oxygen, and it produces carbon dioxide and water. And this is our balanced chemical equation for that combustion reaction. And the delta H is negative 1367 kilojoules per mole, which means it's highly exothermic. Combustion's highly exothermic. That's why in your gasoline that you use to power your car probably, it's usually about 10% ethanol. Some cars can even go up to 85% ethanol for their combustion. So releases a lot of energy. So if I were to take 5 mils of it, right, and I wanted to figure out how much energy was released, I would take 5 mils. Using the density of ethanol being 0.785 grams per mil, we'd have 3.93 grams. Divide that by the molar mass, we get the moles of ethanol. And since we know burning a mole of ethanol will release that much energy, we can say that we would have 117 kilojoules of energy released. I didn't put negative here, I just used the word release, which implies a negative value. If it was a positive value for delta H, that's energy absorbed. Okay. Now, what this looks like, since it's an exothermic reaction, is your potential energy of your reactants are going to be higher than that of your products. In any chemical reaction, it takes energy to break apart the bonds. You have to input energy, and that's going to be the activation energy you see here. But then energy is released as our new interactions form. So if we look at the molecules involved here, we have ethanol, and we have 3 molecules of oxygen, and they react to make 2 molecules of CO2 and 3 molecules of water. So all of these bonds have to break, which is what we see for that activation energy. But the energy required to do that is going to be less than the energy released when the new bonds form. So we get an exothermic reaction, and that heat gets released. The energy also gets released in the form of light. And you'll see that right now as I take that ethanol, make a little pile of it, and then I burn it. Okay? And you can see that energy getting released. Now this is going to be quite a bit different than what would happen in an engine, because in an engine you have your fuel being injected into a fine mist, so your surface area capable of interacting with the oxygen in the air is going to be much higher. In this case, you only have the surface molecules capable of interacting, and therefore that's why you had a nice controlled burn, unlike the demo you're about to see in a minute. You shut this off.